Okay, so today's lesson is 14.6. We're going to be learning the double angle and half angle formulas. You've already learned so far this chapter the trig identities. You've learned the sum and difference formulas for sine, cosine, and tangent. And now we're going to add the double angle and the half angle formulas. To begin with, the double angle formula actually comes from the sum and difference formulas that you did in the section 5. We had sine of two angles being added. What if those two angles were the same angle? So that would be the same as sine theta plus theta is 2 theta. That's this formula we're about to learn right here. Well, if we use the sum formula that you learned in section 5, how does sine of two angles being added expand out? We learned that it makes sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. I've got sine theta, cosine theta, plus another sine theta, cosine theta, because multiplication is commutative. These are the same thing, so we end up with 2 sine theta, cosine theta. That is the first double angle formula. Sine of 2 times theta is equivalent to 2 sine theta, cosine theta. It came from the formula we already know. The first cosine double angle formula also can come from the addition formula we know. So this is the same as cosine of the same angle being added. How does cosine expand out from section 5? Cosine theta. Remember that one is cosine cosine minus the sign switches sine sine. What's cosine theta times cosine theta make? Cosine squared theta minus sine theta times sine theta makes sine squared theta. That's the first rule. So that's the main formula. So they come from our sum and difference formulas. And so we are going to want to know these two patterns. We are going to want to learn these two patterns. So, where do these come from? These are variations of this first one. And they come from using our Pythagorean identities. For example, we might, for some reason in an equation, especially in section 7 when we get to that, want everything to be in terms of sine, which means we need to replace that cosine squared with something that has a sine in it. Well, if you think back, Pythagorean identity says sine squared plus cosine squared equals 1. So cosine squared would be equivalent to 1 minus sine squared. We can replace cosine squared with this. So if we replace cosine squared with 1 minus sine squared, that's where the 1 minus 2 sine squared comes from. So all they did was apply the Pythagorean identity to get rid of the cosine, so all we have is sine. Same thing, you might want everything to be cosine, which means we want to replace sine squared. Well, if we use our Pythagorean identity, sine squared equals 1 minus cosine squared. So we can replace that sine squared with 1 minus cosine squared, distribute the subtraction, the negative, and we get a negative times a negative, a positive. So cosine squared plus cosine squared makes 2 cosine squared. Distribute the negative, you get minus 1. So that's where these two forms come from. And honestly, these two forms are going to come into play more in section 7, where we might have to rewrite a problem that we want only sine in the problem, or we want only cosine. For today, we'll mostly be using the first formula. So example 1 asks us to find the exact value of each expression if we know sine theta equals 4 over 5 and that theta is between 90 and 180. Well, the first thing it says is find sine of 2 theta. So first thing you should do is turn that into its formula. What does sine of a double angle equal? Look back up at your notes. It equals 2 sine theta cosine theta. Then I'm going to build myself a triangle from the sine information, and put it in the correct quadrant. What quadrant will the angle be located in if it's between 90 and 180? It will be between 90 here, 180 here, which means my angle puts me over here. I'm going to drop a vertical and make a right triangle. Who remembers from an earlier chapter, what does sine always equal? It always equals the y-coordinate divided by the radius. The radius is my hypotenuse. So my y is 4, that would be my vertical leg. My radius is 5. What special triangle did I just make? That's right, a 3, 4, 5. What do I know about the x value if I'm going to the left? It is negative. So we now have x, we have y, we have r. We actually do know cosine theta as well. What would cosine of theta equal? X over r, which is negative 3 over 5. So in this problem, we can replace sine theta with what we know it equals. Sine theta equals 4/5. Cosine theta can be replaced with what we found now, negative 3/5. And now multiply your numerators together. 2 times 4 is 8, times negative 3 is negative 24, 5 times 5 is 25. So sine of 2 theta equals negative 24 over 25. So we're going to do the same idea with cosine of a double angle. First, how does cosine of the double angle expand out? We're going to use that first main formula. And what is that formula? Cosine squared theta minus sine squared theta. Okay, again, you probably want to have your formulas handy on this homework as you're getting to know them. We're going to build the same triangle. Well, we already built it, so we don't have to build it again. We know that it's a negative 3, 4, 5 triangle. We know cosine, we know sine, we know everything we need to know for this formula. What does cosine theta equal? Negative 3/5. What are we doing to cosine theta? We're squaring it. Minus. What does sine theta equal? Y over r, 4/5. What are we doing to sine? We're squaring it. What do we get when we square the first fraction? 9 over 25. Minus what do we get when we square the second fraction? 16 over 25. 9 minus 16 is negative 7 over 25. That is what cosine of the double angle formula that is what cosine of the double angle equals. So now we're going to move on to the second set of formulas, the half angle formulas. Let me give you a chance to look over those. Okay, so the half angle formulas, we know that sine of alpha divided by 2, notice we're divided by 2, we're taking half of that angle, is equivalent to positive or negative, and when we do a problem, we're going to talk about how to determine if it's positive or negative, the square root of 1 minus cosine alpha, so whatever is being divided by 2 goes here, all over 2. The cosine half angle formula equals plus or minus the square root of 1 plus cosine alpha all divided by 2. The only major difference is the sine half angle formula is subtraction, the cosine half angle formula is positive. And we, in the problem, are going to have to determine if it's positive or if it's negative. I think the easiest way to do this is to actually work through a problem and see what happens. Sorry, I got distracted. I was just checking something real quick. I'm trying to decide if I need to give you the tangent double angle formula or not, but it looks like there are no tangent double angle problems, so I think we're okay. All right, so we're gonna pick up where we were. Sorry about that. All right, so find cosine of alpha divided by 2, so we're finding the cosine half angle. If we know sine of alpha equals negative 3 over 4, and we know that alpha is in the third quadrant. So the first thing I do is I write out the formula that I'm working with. So since it's cosine of the half angle, I'm working with positive or negative square root 1 plus cosine alpha divided by 2. Now, I need to know what cosine of alpha is. And they were nice enough to give me sine of alpha, but I'm going to have to do a little more work to find cosine of alpha. So I'm going to figure out, where is alpha located? Well, alpha is in the third quadrant. So I'm going to draw, alpha puts me in the third quadrant, and create my right triangle. If I know sine, what parts of the triangle do I know? I know y over r. So my y coordinate is 3, my radius is 4. Which one's negative? The y is, because I'm going down and radius will always be positive. And I need to find my x. Is this a special triangle? It is not. 3, 4, 5. 5 would be your hypotenuse, your longest side. This is my hypotenuse. So how do I get my x? My Pythagorean theorem. So x squared plus negative 3 squared equals 4 squared. X squared plus 9 equals 16. X squared equals 7. So x equals plus or minus root 7. How do I decide if it's positive or negative? Based on where it's located. If I'm going to the left, then x will be negative root 7. So now I have all my parts. I needed to know cosine of alpha. Well, cosine alpha equals what? X over r. X is negative root 7. R is 4. So in this problem, I'm going to put plus or minus square root of 1 negative, so minus root 7 over 4, all divided by 2. We're going to have to simplify that. But first, I like to decide about the positive and the negative. And that's where the location of alpha is important. If alpha is in the third quadrant, what two angles is it between? Third quadrant is between 180 and 270. We're interested in where alpha divided by 2 is located. Well, if alpha is between 180 and 270, how would I figure out where alpha divided by 2 is located? I would divide everything by 2. So alpha, the half angles between 90 and what's half of 270? 135, which means the half angle is between 90 and here's 135. So this is where I'm located, right here, somewhere between there. Well, what would cosine be in this position? All students, cosine would be negative. So that means I take away the positive. My answer is going to be negative. So then I look at this and I say to myself, that's great, except what's wrong with what I'm looking at? It's awfully complex. That's right, I've got a complex fraction. I think the easiest way to simplify this complex fraction inside of here is to multiply the numerator and the denominator by the common denominator of the little fractions. What would be the common denominator of the only little fraction? 4. So I'm going to multiply my top row by 4, my bottom row by 4. That gives me negative square root of 4 times 1 is 4 minus, what do I get when I do 4 times the fraction? Root 7, all divided by 4 times 2 is 8. I was looking to see if your book decided to simplify that even more. It does appear that they simplified it even more. So from here, we're going to keep simplifying. I'm going to erase this work so I have room. They're going to actually simplify root 8 on the bottom. So the numerator stays negative. Don't forget that negative sign. 4 minus root 7 over, how do I break down the square root of 8? That's right, it's going to be 2 root 2. Then they kept going because what's wrong with this answer? You can't have a radical on the bottom. How do I fix that? I multiply bottom and top by root 2. The bottom's easy. What's 2 root 2 times root 2? It's going to be 4. Top is negative. square root of. Can I distribute root 2 into this square root since they're all square roots? Yes, you can. Square root of 2 times square root of 4 gives me square root of 8 minus square root of 2 times this square root will give me 2 root 7. That root 7 is a different square root that's on the inside. So they did keep simplifying. I know that's a little difficult, a little bit of funky algebra going on here. Right here, when we distribute, I'm trying to think of a good way. If we had 2 times root 3, we can't do anything. But if we had root 2 times root 3, we know that makes root 6. Agree? So that's what's going on here. They're saying root 2 times root 4 gives me root 8. Root 2 times square root 7. This root times this root puts the 2 on the inside, but this root 7 is another square root inside of that. Hope that makes sense. Okay, so walk us through this again. Half angle, figure out the formula you're using. Find cosine alpha. We did that by making a triangle. Then decide if it's positive or negative by deciding where alpha divided by 2 would be. That's what we did here. And then after that, it involves some algebra simplification. The hardest part of the half angle formula is usually the algebra simplification. Go figure, it's the algebra. So let's go on to page 2. Find the exact value of each expression using the half angle formulas. So we want to find exact values. Exact values means we're going to be working with those values you've memorized. 30, 45, 60, all those values. So we look at 105 degrees. I want to use a half angle formula. So I've got to think to myself, what angle can I divide by 2 that gives me 105, and that angle that I'm dividing by 2 ultimately has a reference of 30, 45, or 60. I divide 210 by 2. So sine of 210 degrees divided by 2 is what we're working with. And we're using the sine half angle formula. So it's positive or negative, square root. Since its sine, is it 1 minus cosine or is it 1 plus cosine? It's 1 minus cosine, all divided by 2. So first thing I can do is in this formula, I now know what alpha is. Alpha is 210, so in my formula, I know that's 210 degrees. We're going to simplify that first. Cosine of 210 degrees is something we know how to find. Where is 210 degrees located? Third quadrant. What's the reference angle? 30 degrees. So cosine of 30 degrees is something we know. What's cosine of 30 degrees? It is root 3 over 2. So 210 is root 3 over 2, but then all students take, what's cosine going to be? Negative. So in place of cosine 210, I can now replace it with negative root 3 over 2. So I have 1 minus negative. What's going to happen to two negatives? They become positive over 2. Then I have to decide about the positive or negative out front. It is based on the original angle. Where is 100? And that's your half angle. 210 divided by 2 is 105. Where is 105 located? In the second quadrant. What is sine in the second quadrant? It will be positive. So this is going to be positive. And then I just need to clean this up some. So we've got 1 plus root 3 over 2 over 2. What's wrong with this? It's complex. What can I multiply the numerator and denominator by? 2. So we get the square root of 2 plus root 3 over 4. Should we simplify it if we can? We can simplify the denominator. So we get root 2 plus root 3 over, what's the square root of 4? 2. Good. So if we walk through this again, First, we need to find what we divide by 2 to make 105. That angle goes where alpha is. We get that exact value. Then we decide positive or negative based on where this original angle is located, sine of 105, and then we simplify. So let's do another one of these with radians. Cosine of pi over 8. So we need to decide, what am I taking half of? What am I dividing by 2? It's a half angle. What am I taking half of to make pi over 8? I am dividing pi over 4 by 2. Half of, you do 1/2 of pi over 4, that gives me pi over 8. So I'm using pi over 4 divided by 2. This is the cosine half angle formula. So it's positive or negative square root. Since its cosine is at 1 plus or 1 minus, is 1 plus cosine of alpha. What is alpha? Alpha is this angle we're dividing by 2. All divided by 2. Cosine of pi over 4, that's something we know. We don't have to get a reference angle. Cosine of pi over 4 is root 2 over 2. Out front, we have to decide positive or negative. Well, we determine that based on this original angle. Where is pi over 8 located? Quadrant 1. So what is cosine in the first quadrant? Positive. Good. It's going to be positive. And what do we not like? Complex fraction. What can we multiply the top by and the bottom by? 2. We distribute. We get positive square root 2 plus root 2 all over, sorry, Ms. Conrad's skipping ahead, all over 4. Can we take the square root of anything? We can take the square root of the 4. So square root 2 plus root 2 over 2. Good. Last example. The other thing we might be asked to do with our half and double angles is verify some identities. So we want to verify identities. Remember what that means. That means you've got to show that one side turns out to look just like the other side. We're going to start with the one that's more complicated, which appears to be the left side. It's asking me to square this. If I asked you to square x plus 3, could you just make it x squared plus 9? No. If I ask you to do x plus 3 squared, what am I asking you to do? Write it twice, and then you multiply, you FOIL. Same thing here, I'm asking you to multiply sine theta plus cosine theta times sine theta plus cosine theta. So we distribute. What's sine times sine? Sine squared. What's sine times cosine? Sine theta, cosine theta. What's cosine times sine? Same thing. And what's cosine times cosine? Cosine squared. We got 2 of these. So when we add those together, we get 2 sine theta, cosine theta. And then we have sine squared plus cosine squared. Where have we seen sine squared plus cosine squared before? That's right. Sine squared plus cosine squared always equals 1. It's your Pythagorean identity. So sine squared plus cosine squared makes 1. Starting to look a lot like this. What do we know sine of 2 theta is? We know that sine of 2 theta is a formula we learned today. It's the sine double angle formula. How does that expand? 2 sine theta, cosine theta. The left side and right side match. Good. So let's look at the last example. Which side looks more complicated? The left. So we're going to start with that. So, any ideas? Well, I see cosine double angle. Over here I see sine of just a regular angle, cosine squared of just a regular angle. So that double angle looks out of place to me, because it is. So the first thing we want to do is rewrite cosine using its double angle formula. So we have options here. We can either use the first formula, the second formula, or the third formula, because remember this has 3 formats. I personally think the easiest thing to do is to use the first. So I'm going to use the first one. So sine theta times cosine squared theta minus, what is the cosine double angle first formula? It is cosine squared minus sine squared. Now we're subtracting this whole thing, so we've got to distribute the negative. So we get cosine squared minus cosine squared. What are the cosine squareds going to do? That's right, they're going to cancel. Then we distribute it, so we've got sine theta out front. And then we distribute this negative. What's negative times negative sine squared make? Positive sine squared. What's sine times sine squared make? It makes sine cubed. The left side, it does indeed verify the right side. Good, so that is the end of that lesson. So we'll go over homework next class.